Hi, everyone. So today I'm going to be talking about the concept of discipline in Scientonomy, what it is, what the important aspects of it are, and then I'm going to be providing a case study of sorts. So the transition from alchemy to chemistry in Western European science that Paul and I published a paper on just a couple months ago. First of all, let's start out with what disciplines are generally. So, disciplinary communities devoted to the production of new knowledge are a distinctly modern phenomenon. In 18th and 19th century Europe, natural science faculties arose at universities. Disciplinary communities devoted to production of knowledge in specific fields were formed. But just because disciplinary communities in their modern iteration are a modern phenomenon, the practice of dividing knowledge into classes or categories is a universal feature of knowledge, at least we think. Prior to the 18th century, distinct areas of knowledge were identified and classified primarily to organize teaching, instruction, and writing. For example, the idea of the liberal arts going back to ancient Greece and Rome and education there. So, a database of intellectual history, like we are aspiring to create, should also record the views of various agents on disciplinary divisions, such as Agent A accepted discipline D at time T. So, to that end, we need a proper scientonomic notion of discipline, what it is, and how it's related to questions and theories. So, we're going to start, like I said, with the concept of discipline in the scientonomic ontology, and then we're going to move into the case studies. So, to talk about disciplines, first we need to talk about questions. So it's great that this presentation is right after Nikki's. So a sub-question is, a question Q is a sub-question of another question Q prime, if and only if any direct answer to Q is also a partial answer to Q prime. So essentially, questions form hierarchies. Questions can be sub-questions of broader questions and have other questions as their sub-questions. So for example here, who were the emperors of Russia is both a sub-question of who were the rulers of Russia, as any answer to who were the emperors of Russia can also answer the question who were the rulers of Russia. And then was Peter the Great an emperor of Russia is a sub-question of who were the emperors of Russia, because the answer to that question also answers the question as a partial answer to the question who were the emperors of Russia. And as you can see, more complicated hierarchies of questions are a key feature of disciplines. So, for example, here we have, how did animals originate as a result of evolution? This is a sub-question of the question, how did living species originate as a result of evolution? Any question has its place within a hierarchy of related questions of broader or narrower scope. So a discipline is characterized by its core questions. So the core question of a discipline is a question identified in the discipline's delineating theory as definitive of the discipline. So what is a delineating theory? It's the other thing that characterizes a discipline. The two work in tandem. A delineating theory is a second-order theory identifying the set of core questions of the discipline. So, for example, a delineating theory might be formulated like, the discipline chemistry is characterized by the question, how are substances composed and broken down? And so that delineating theory references the core question, and the core question is identified in the delineating theory. It's kind of a circular relationship. So going back to the tree of the question hierarchy that we were looking at earlier, we can see that the question at the top of the hierarchy is a core question of evolutionary biology. How did living species originate as a result of evolution? And then its sub-questions are all questions that are also dealt with by evolutionary biologists. They're more specific, whereas the core question is necessarily very broad. So now we can move into how we define a discipline. A discipline is characterized by a non-empty set of core questions Q, and the delineating theory stating that Q are the core questions of the discipline. So a discipline and its delineating theory are in a one-to-one relationship. Each discipline has one and only one delineating theory. A discipline includes at least one question, and a question can be part of any number of disciplines. We can think about how chemists and physicists, there's a lot of overlap in the questions that they pursue. And then a discipline similarly can include any number of theories, and a theory can be part of any number of disciplines. So all sub-questions, as I said, of core questions also fall within the scope of the discipline. So any evolutionary biologist might consider the specific question about the Mexican blind cave fish. It's inherently part of that discipline because it's a sub-question of its core question. However, sub-questions are not essential to a discipline. Sub-questions can be rejected or simply, for whatever reason, not pursued at one moment in time. Disciplines have core questions and they also have core theories. A core theory of a discipline is a theory presupposed by the discipline's core questions. So here we have the core theory of evolutionary biology being living species originated as a result of evolution, because this theory is presupposed by the question, how did living species originate as a result of evolution? So a theory belongs to a discipline if it is presupposed by the discipline's core questions, or if it answers any of the questions of the discipline. It doesn't have to answer a core question of the discipline, it can answer any of its questions to be part of said discipline. So, how do we accept a discipline? To accept a discipline, it's not sufficient to just accept its delineating theory. The agent also must accept the core questions of the discipline. A really good example for this, and one that we also referenced in our alchemy paper, is that of astrology. So anyone knows what astrology is, essentially. Even non-astrologers would readily accept the delineating theory of astrology. That is, the statement that questions such as how did the positions of the planets at the time of one's birth influence one's character are core questions of astrology. We know that those questions are what define astrology. However, this is not the same as accepting astrology. The latter also requires the acceptance of astrology's core questions, which we do not do. We do not think that how do the positions of the planets at the time of one's birth influence one's character is a question that we should pursue. So we accept the delineating theory of astrology, but we do not accept the discipline. We do not see the discipline as legitimate. So, therefore, a discipline is said to be accepted by an epistemic agent if that agent accepts the core questions specified in the discipline's delineating theory, as well as the delineating theory itself. You must have both. So, the historians claim that agent A accepted discipline D at time t, like we want to eventually have in our database, amounts to the following. Agent A accepted delineating theory T at time t. Agent A accepted core question Q1 at time t. Agent A accepted core question Q2 at time t, and so on for all of the core questions. All right, so now that we've gone over the concept of discipline in the Scientonomic ontology, I'm ready to move on to briefly talking about the case study in my paper with Paul. Before I get into that, if there's anything unclear about disciplines and anybody has a question that they think they'll need answered to understand a case study, just let me know now, and if not, I can move on. We're good? All right, great. So, chemistry and alchemy. In the popular conscience, they're very separate, diametrically opposed disciplines. And this was also supposed by historians of science for most of the last century. For example, Helena Metziger was an important historian of science, and in her 1923 work, she compared chemistry and alchemy as alchemy being vitalistic and organic, while chemistry was scientific, corpuscular, and mechanistic. She viewed the two as entirely incompatible. They were entirely different disciplines. 30 years later, Marie Boas-Hall, another important historian of science, viewed alchemy as archaic, irrational, and even consciously fraudulent, while characterizing the discipline of chemistry as modern, scientific, and rational. Paul even thought that the very existence of the two words, alchemy and chemistry, was a sufficient argument for the existence of two separate disciplines. It was impossible for a discipline to be continuous under two different names. We're going to see that that's not necessarily true. And then even more recently, Marco Beretta's book, The Enlightenment of Matter, he asserts that alchemy had always been a separate discipline from chemistry. So this is just 30 years ago. However, at the turn of the century, so the late 90s and early 2000s, a series of papers published by Principi and Newman proposed a different view. Their view is that alchemy and chemistry have been separated by historians of science not because they were different disciplines, but because of an etymological error that was codified. Certain questions began to be associated with the word alchemy because of a misunderstanding of where that word derived from, and then retroactively, the distinction was applied. The assumption that alchemy and chemistry refer to separate disciplines prior to the very late 17th century is misleading, and attempts to separate them are futile. In fact, the terms were used interchangeably to refer to the same discipline up until the end of the 17th century. So, throughout this presentation, I will be using the term chemistry for the chemical discipline from the 17th century to the early 18th century to better reflect its continuity and to avoid the persistent and negative connotations of alchemy. Even if we all now understand that alchemy is not necessarily diametrically opposed to chemistry, it is hard to shake those connotations of vitalism and mysticism and so on. So chemistry is a good term, and it reflects the continuity of the discipline. We consider Newman and Principi's view to have been accepted by historians of early modern science. The paper has seen numerous citations, especially in the last 10 years. There aren't a lot of people working on like alchemy and chemistry in the early modern period, but I mean, in all of the scholarship that Paula and I read, Newman and Principi, and all of their work was cited several times. So what we want to know is if the scientonomic concept of discipline can visualize, investigate, or elucidate this interesting transition. If we just go back, Newman and Principi kind of suggest that this transition occurred at the very late 17th century, but they don't specify an exact timeline or the exact dynamics of how the split ultimately happened or was retroactively assumed. So we want to know if tracking the core questions of alchemy and then chemistry can help us to better understand this transition. So first, we identified chemistry's core question, or what we think was the core question of chemistry, by the early 17th century. So we think that this question is, how can substances be broken down or analyzed and composed of other substances or synthesized? So we looked at various different terms that were used for the discipline by contemporary textbook authors and chemists, as well as other writing. So one synonym for chemistry used by Paracelsus and repeated by later textbook authors was spagyria. This appeared in the 16th century, and the word was thought to be derived from the Greek root words span, to pull apart, and aigerein, to put together. So inherent in this alternate title is the idea of analysis and synthesis. Then at the turn of the 17th century, a textbook author, Libavius, wrote that chemistry deals with synkrisis, another Greek word which means coagulation, and diakrisis, which means dissolution. So again, we have this idea of breaking down and putting together as the core idea of what chemistry deals with. And then Jean Peguin, writing just a bit after Libavius, another influential textbook author from the early 17th century, wrote, "It is said that chemia teaches par excellence to dissolve and to coagulate. If one should call chemistry spagyria, he denotes its principal operations, namely synkrisis and diakrisis." So all of these different terms, which all mean similar things, were kind of synthesized by these textbook authors and said to be definitive of the discipline. So we think it's reasonable then to assume that the core question of chemistry before at least 1660 was concerned with analysis and synthesis. So from this question, we can develop a preliminary question hierarchy for what chemistry looked like in the early 17th century. So two key sub-questions of this question are, how can changes be brought about in minerals, plants, and animals, and how can the philosopher's stone be produced? When you're looking at these questions, you might immediately identify one as chemical that we still deal with in chemistry today, and one as alchemical. Also, we want to know, of course, that the question, how can the philosopher's stone be produced, presupposes that the philosopher's stone can be produced. So we base this initial distinction when crafting our question hierarchy off of an influential textbook author. He was writing in 1655, so right before the 1660s, which is our period of interest for when the discipline started to change. And he divided the discipline into two proto-subdisciplines, Chimie universelle, so all questions dealing with the philosopher's stone, and Chimie particulière, so questions dealing with everything else. So this seems like an intuitive way to organize the question hierarchy, as it was recognized as an organization of questions dealt with by chemists, by scientists of the time. I'm going to show all of these later, more close up, so don't worry. But here is the ultimate question hierarchy that we came up with. Of course, this is by no means expansive, and it's very provisional. What's listed here is just what was important for us to track and what we were really able to track, either staying the same or changing, remaining accepted or being rejected. So our argument is that in the 1660s to about the 1720s, the questions that have been highlighted became a subdiscipline of chemistry. They became the core questions of the subdiscipline, alchemy. So around the 1660s, these questions all became grouped together under the label of alchemical. That is, alchemy became a subdiscipline of chemistry. So, for example, Rolfink was a 17th century chemical textbook author who initially used the terms alchemy and chemistry interchangeably in his earlier work. But by the 1660s, he was only using alchemy to refer to chrysopoietic questions. So, chrysopoeia is the transmutation of any metal into gold. And then in 1663, Lazare, a French textbook author, wrote that, while the terms alchemy and chemistry had been used interchangeably in the past, alchemy should only be attached to questions of the philosopher's stone and transmutation. So again, we have an author who noted the terms were interchangeable before, but now is attempting to restrict this descriptor of alchemy to a specific hierarchy of questions. And then 1 year later, in 1664, another author wrote that alchemy is concerned with the transmutation of metals and the preparation of the elixir being the philosopher's stone, while chemistry deals with questions concerning the preparations of extracts and juices. Obviously, this is maybe a more narrow definition of chemistry than we otherwise find, but it's clear that the questions concerning extracts and juices are not related to the questions that we've labeled as alchemical. So here are the core questions of the subdiscipline of alchemy as of 1660 that we identified. How can metals be transmuted to one another? And especially, how can base metals be transmuted to precious metals? How can the philosopher's stone be produced? And how can a cure-all medicine be made from minerals, plants, and animals? So even though all questions of metal transmutation are alchemical, the transmutational questions that appear most often and are most associated with the discipline concern either transmutation into gold, chrysopoeia, or into silver, argyropoeia. But any question of transmutation would have been considered alchemical. But the ones that you'll see most often and the ones that are easiest to track particularly pertain to transmutation into gold, and that idea has persisted into the popular conscious today. So it is worth it to just quickly review the definition of subdiscipline. So a subdiscipline is in itself a discipline, and a subdiscipline is a discipline A is a subdiscipline of another discipline B if and only if the set of questions of A, QA, is a proper subset of the questions of B, QB. So as we've seen, all of the questions of alchemy, or at least its core questions, are all form a proper subset of the questions of chemistry because they are all in its question hierarchy deriving from its core question. One textbook author of the Académie Royale des Sciences, writing at the end of the 17th century, noted that alchemy was a particular science within chemistry that taught the transmutation of metals. So even the contemporary understanding of alchemy's place within chemistry by the end of the 17th century does closely align and can be mapped onto our concept of discipline and subdiscipline. So alchemical questions, we believe, were rejected by the 1720s. So we're going to look at two authors writing 10 years apart and the theories that they accepted and the questions that they saw as pursuit-worthy. So Weddell was writing in 1705, and he accepted some experimental evidence for chrysopoeia and wrote about it in his a very substantial textbook on chemistry, while also accepting that some extant alchemical pursuits may be fraudulent. He warned about it in that textbook as well. But he wanted to start an alchemical research group, so he clearly accepted alchemical questions while being aware that some experimental evidence had been fabricated. But 10 years later, Stahl decried the possibility of chrysopoeia in all his chemical research published after 1715 and called all experimental evidence put forth fraudulent. So the question of the transmutation of base metals must have at least been rejected by Stahl by this point because it is incompatible with the theory that he accepts that base metals cannot be transmuted to precious metals. So within a period of about 10 or 20 years, many of these alchemical questions had been rejected, at least by individual influential chemists. Similarly, the question of the philosopher's stone, after 1724, the French Académie des Sciences, which we might remember that most of the influential textbook authors that we've been looking at were French and associated with the Académie, published no more research on this question, as well as on other alchemical questions. But this move came after the publication of a 1722 work, which rejected that the philosopher's stone could be produced at all. Instead, the author summarized a list of cheats used by alchemists to fabricate their transmutations. Later that year, another work was published that used these cheats and the concept of the philosopher's stone to differentiate between alchemists and real chemists. Alchemists were those who pursued the question of the production of the philosopher's stone, whereas real chemists rejected this question. So we ultimately figure that this is the state of things after the 1720s. The questions on the left side of the diagram remain in chemistry after the 1720s, whereas the questions on the right The alchemical questions were ultimately all rejected. But chemistry's core question remained the same, at least for the next century or two. Principi identified the unifying features of the chemical discipline through the 18th century as questions about analysis, synthesis, transformation, and production of material substances. And we found that the last two questions on the latter two topics can be subsumed to a core question about analysis and synthesis and a question hierarchy. Like, for example, in the hierarchy that we showed earlier, questions about the production of metals, we subsume that to questions about analysis and synthesis generally. So we think it's still justified to say that the core question pertained chiefly to analysis and synthesis. And an 1838 textbook, which was also very influential, its introduction states that all chemical knowledge is founded on analysis and synthesis. And this was more than 100 years after the rejection of alchemy, showing that the core question of chemistry was relatively static. So we're going to return really quickly to the concept of discipline acceptance. Again, a discipline is said to be accepted if an agent accepts the core questions specified, as well as the delineating theory of the discipline. So since subdisciplines are themselves disciplines, they also follow the same mechanism of acceptance or rejection. Hence, a subdiscipline can be accepted or rejected. However, the chemical discipline's core question was never rejected, nor was its delineating theory. It was identified by contemporaneous scientists as a continuous discipline despite differing names. Scientists in the early 18th century who only called themselves chemists were students or correspondents with scientists who still referred to the discipline or parts of the discipline as alchemy. It had a continuous intellectual heritage, and the discipline was understood to be relatively the same at its core. So, in summary, indicators for the core questions of a discipline include textbooks, academic publications, and academic appointments. We found textbooks especially helpful because usually what's in the introduction to a textbook will frame everything that's presented in it. And for us, that helped in crafting our core question hierarchies. Tracking core questions allows us to explicate and diagram the dynamics of historical scientific disciplines because we're able to follow where these questions show up, what agents accept them, and if they're ultimately rejected. Our scientonomic formulation of discipline potentially allows us to more precisely identify the time period of discipline rejection or subdiscipline formulation. This is really important for observational scientonomy. Discipline rejection here was a two-step process. Firstly, a subdiscipline was formed, and secondly, the subdiscipline was rejected. Newman and Principi, well, they also identify all of these key textbook authors and key academic appointments have a more nebulous picture of when exactly alchemy was rejected at the end of the 17th century, whereas we can date it to the decade, the 1660s to the 1720s. Finally, this case study clarifies that acceptance of the delineating theory does not entail accepting a discipline in line with Patton and Al-Zayati. Clearly, after alchemy was rejected, the delineating theory for alchemy as a subdiscipline was still accepted, but all of those questions were clearly and cleanly rejected. So that's my presentation. Thank you for listening.
So as usual, I turn on the microphone so you all can feel the vibe here, right? Clapping. Yeah, so for the sake of time, we're gonna have one question, and if you still have time, maybe a second question. But for now, one question. Nicola has a question. Nicola, go ahead.
Thank you. Thank you for this talk. Actually, I was wondering whether you might consider adding more other elements to the theory and the theories and questions in modeling what delineate disciplines or subdiscipline. For instance, practical needs or more externalist factor to use a concept from the history of science.
I think that more research would probably be needed to determine if we could add more elements to our understanding of disciplines, because currently they do seem to square fairly well with our scientonomic theories and questions. It seems like all of the dynamics of that transition were relatively well explained by what we already have, but it's only one case study, and it's a very well-studied and attested case study. So I'm not sure if in other cases of maybe more nebulous disciplinary transition, if something else would be needed.
Can I also give an answer to that? We have had some other elements. I mentioned yesterday in my talk about the ontology, the idea of epistemic tools and instruments as they're used in science and how they're related to the method of the agent. We don't explicitly have a way of excluding external influences yet, but it's sort of implicitly there in some of the things we've already done. But the ontology is still a work in progress.
And it's also worth mentioning that later today we are going to have a talk on a work in progress by Andrew and Rebecca, who will be trying to make a case that there is more to disciplines than just core theories and core questions. Specifically, they'll be arguing that there's also such thing as a core method or something like that. So it goes beyond that. But these things prove to be very difficult, notoriously difficult to show in practice. Because other things being equal, you stick to what you have and say, okay, can we explain it with the means we have? And in most cases that we discuss, it seems like, yeah, we managed to explain with the means we have. And then why do you need something else, right? So there's always this pressure of showing in a clear-cut fashion that, yes, you do need something else for this particular case. And if you manage to show it at least once, then you have a case, right? So.
Okay, thank you so much, Izzy.